Okay, so remember with limiting reactants, first you're going to have amounts for 2 or more reactants. I will only ever give you 2. So you're going to do the stoichiometry for both reactants. And that means find the theoretical yield. Now, if you have a question that says, what is the limiting reactant, but it doesn't tell you, it doesn't say what's the theoretical yield of and give the name of a product, you can pick whichever product you want. All you have to do is figure out which one gives you more of any of the products, because if it gives you more of one, it's going to give you more of the other. Rather, you want the one that gives you less. Okay, so whichever gives less product, limit, right? And then that smaller amount is the theoretical yield. All right, so we had looked at number 6, and I had skipped over number 5. Now, often what I will do is I will put a limiting reactant question that is just moles as part of your multiple choice because it's less math. All you have to do is go from moles of one to moles of the other. So that's step 2 in your stoichiometry equation. So let's look at number 5. And remember, we're dealing with this reaction for the formation of water, right? And it says, if you have 1.73 moles of H2 and 0.89 moles of O2, which would be the limiting reactant, and how many moles of water can you produce? Okay, so it's asking both for the limiting reactant and the theoretical yield. So we need to find how much product we get from each of these, but this is just a mole to mole, one-step process. We don't have to go to find moles because we're already there. And then once we've converted from moles of one to moles of the other, it just asks how many moles, so we can stop. We don't have to go to grams. All right, so for hydrogen, 1.73 moles of H2. And then I'm going from moles of H2 to moles of the product because I really want to know how much product I'm going to get. I can answer the question by going to oxygen, but I can answer the first question, but I can't tell how much product I get. So I'm going to go to the water. So for a limiting reactant problem, the top chemical is going to be your product. Your bottom chemical is going to be your reactant. Where am I going to get the numbers from? The balanced chemical equation. So for water, it turns out it's the same number. Okay, so I start with this number of moles, I end up with that number of moles. I can do that math in my head. Okay, so remember, in each of these, I'm testing. This is my test case. What if hydrogen is limiting and I have way more oxygen than I need? What if oxygen is limiting and I have way more hydrogen than I need? Okay, so I'm not going to get both of these results. I'm going to have to pick one in the end. All right, so again, we want our product on top. And we want the thing we're coming from, our known oxygen, on the bottom. Now, notice this is different from some of the stoichiometry we've done in the past. When we had solution stoichiometry, they gave us information about 2 chemicals that were reactants, and then we just went from one of those to the other. If it is a limiting reactant problem, we're going to something we know nothing about. The product we don't have any information about at all other than its chemical formula. Okay? All right, so I'm going to double this, and this is going to be 1.78 if I do that correctly. Yeah. All right. Technically, do I have right sig figs here? No, because I only have 2 sig figs, so technically I should round this to 1.8 moles. and my moles of oxygen cancels, and I'm left with moles of water. Okay, so I've done it twice. What is my theoretical yield? The 1.73, the smaller amount. So the theoretical yield is whichever one is smaller. And the limiting reactant is the reactant that got me there. In this case, the hydrogen. Okay, so this is apt to be in a multiple choice question. I'd probably have something with two products, and when I ask what the limiting reactant is, each of the chemicals in there is going to be one of your choices. And you're going to say, wait a minute, water is not a reactant. That can't possibly be the answer. So you're immediately going to cross off all of the products because they're not reactants. And you're only going to look at the two reactants. And then you have to decide which one limits it. Okay. So you can make your multiple choice question a 50-50. All right. Let's look at the first problem. It tells you what the limiting reactant is, so that doesn't really help us. That's just a theoretical yield kind of problem. Let's go on to the second problem. That one's more of a limiting reactant one. So we are given this reaction. Anybody remember the name of this chemical? So since we have a carbon, it's organic and it uses the organic naming rule. So it starts with meth. And if there's only hydrogen, then it becomes methane. Okay, so this is methane plus 2, you may remember this one, ammonia. We all know oxygen is diatomic. And then we have 2. Here's one of our new acids we have to name. So Cn as an ion, Cn minus is what? Cyanide. There's no oxygen, so we say hydrocyanic acid. Water. All right. And so this says we have 100 kilograms of each reactant. Let's just do grams rather than kilograms. I don't want to have to do the 1,000 conversion. Okay. So we have 100, and I'm going to put point there so that we get 3 sig figs, 100 grams of each of these. All right. Now, if they give us grams, we need molar weight. If they don't give us grams, then probably it's a solution and we need to use molarity. But in this case, they gave us grams. So I know oxygen is going to be 32 because each of those is 16. Take a second to find the molar weight of the other two. All right, did you come up with those numbers? Now, what you have for the last digit is really going to depend on, did you use 1.01 for hydrogen? Did you use 1.008? Did you use 1.0078? So how many sig figs you used on the hydrogen will make a difference in the last digit. Ultimately, it's not going to matter for our answer because we're only going to use 3 sig figs. How do we find the mole? So this is the mass. This is the molar weight. How do we find moles? We have 4 mathematical operations: add, subtract, multiply, divide. Which one are we going to do? Divide. Good guess, though. So we have grams. We want to divide grams to get rid of grams. That's why we're going to divide. Okay, so we're going to divide here to get our moles of each of these. All right, so pull out your calculators. Now, in each case, when you divide, the 100 should be the first number you put in. So we're dividing the amount. Remember, we start with the amount, which is a mass or a volume, the amount divided by the conversion factor. All right, who has an answer for the methane, the first one? Shout it out. I heard the 6. Sorry. Okay, so 6.23, 100 divided by that, yeah, 16 goes in there, so 6.23. What do we have for this one? 5.87. Okay. These are moles. And then for our last one, okay, 2 moles here. Okay, so normally you will only have 2. I will only ever give you 2 reactants, but like I said, it could be more. And in this case, it is more.
On the last one, it's 3.125, do you round to 3.13 or just leave it?
So for me, I don't care. The rule is round to the even number. So since 2 is even, we would round to the 2. The idea is half the time you should round up and half the time you should round down. So if you always round to the odd number, you're accomplishing the same thing as if you always round to the even.
Oh.
That's why I don't care. Okay. So we're going to have to check for each of the reactants. So for CH4, we have 6.23 moles of the methane. So I'm going to keep my chemical. Anytime I do stoichiometry, I want to have the chemicals in the formula or in my equation so I don't lose track of where I am. So my first step in the stoichiometry was this. Now I'm going to do the second step. So I'm going to have moles of CH4 and I'm going to go to moles of product. Now it's going to ask me in the end for one of those. So it says how much hydrogen cyanide, which is what we would call it if it wasn't dissolved. How much hydrogen cyanide? Balanced chemical equation. So 2 for the methane and 2 for the cyanide. That makes that part of the math really easy. I'm going to go ahead and do the last step added on here. This third step is the same for each of them, going from moles of HCN to the mass, grams of HCN. So we're going to have, I think that's 27 grams per mole. All right, so I'm going to leave that for some of you to calculate, and I'm going to set up the other 2. They're going to look just the same, except for this ratio here is going to have a different number on the bottom. The top number will be the same. So I get 168 grams of hydrogen cyanide. So we're going to go through that same process with ammonia. Take the moles of ammonia. Make sure I have number, unit, and chemical. And that way, when I set up my step 2 conversion, I know what chemical to put on the bottom. I'm trying to get rid of ammonia, so that's going to go on the bottom. And for limiting reactants, every hypothetical is going to go to the same product. So this is moles of HCN. And again, my numbers for step 2 come from the balanced chemical equation. Take those coefficients. And then the last step is the same for each hypothetical. So hypothetically, if I have 5.87 moles of ammonia, I should end up with 159 grams of hydrogen cyanide. All right, so one more to do. Hypothetically, if I'm limited to 3.12 moles of oxygen, how much hydrogen cyanide can I get? So I put my 3.12 moles of oxygen. And now when I pull my coefficients, of course, HCN hasn't changed, but oxygen is different. Oxygen is 3. So that's going to make a difference in what my outcome is going to be. But my last step is going to look identical for all of them, multiplying by the molar mass of the HCN. So take a moment to plug that in, see what you get. And I get 56.3 grams of HCN. Remember, I get 3 sig figs, so this time I have to go past the decimal because I didn't have anything in the hundreds place. All right, so we don't get all of these things. Remember, this is hypothetically if methane was my limiting, hypothetically if ammonia was my limiting, and hypothetically, if oxygen is my limiting, but I am limited to the amount. So I take the amount that I get from my limiting reactant. And since I'm limited, that means I need the smallest amount. So the 56.3 is my theoretical yield. Then when I decide what my limiting reactant is, I just go back to whatever reactant gave me that theoretical yield. So oxygen is my limiting reactant. All right, I handed you out a paper that has different types of reactions for practice. We don't have a chance to go through this in class, but you can use this as practice, and I will post the answers on Canvas so you can check yourself.